Good evening, ladies and gentlemen. Center of Excellence in Safety Engineering and Analytics, IIT Kharagpur, welcomes all the participants to the weekend talk on Safety Engineering Management and Analytics, abbreviated as SEMA, a Government of India initiative commemorating 75 years of India's independence. So, as always, we initiate our program with this wonderful shloka. Asatoma Sadgamaya, Tamasoma Jyotirgamaya, Mrityorma Amritam Gamaya, which inspires this entire human fraternity to lead from the ignorance to the truth, from darkness to light, and from death to immortality. So with this, myself, Mom Mitra from Tata Steel, along with Sinjana, Ashish, and Shovik, our co-moderators from IIT Kharagpur, welcome you to this weekend talk. Ladies and gentlemen, today we have a very knowledgeable speaker with us. We have Mr. Nelson Davis Pallipuram. He is a scientist engineer from Indian Space Research Organization. He is responsible for driving safety across the Vikram Sarabhai Space Center, ISRO. He is a safety professional with experience in major engineering industries, R&D, processing and testing of systems for space applications. This also includes the experience in processing of space ordnance systems and its testing. He also functions as a project manager for the greenfield projects of ISRO for defining the safety requirements in the conception phase, design of the process, establishing an operational phase. He provides proponent support by safety engineering studies for the safety review, assessing the potential hazards and evaluating the control measures for activities at the Space Center. He started his professional career as a graduate engineer trainee at Jindal Steel and Power Limited, an integrated steel plant at Raigad. He also had a stint at Tata Steel Jamshedpur as manager in process safety, gas safety, and disaster management. And he holds a master's degree in industrial safety engineering from the National Institute of Technology, Tiruchirappalli. And his topic today is prevention through design, total safety model. With this, I will request our chairman, CoE, Professor J. Maiti, to formally welcome our expert speaker today.
Thank you, Mom. Thank you, Mr. Nelson. We are so pleased and privileged today because safety in the space, when talking about our missiles and other things, I think this is another extreme. We talk about industrial safety, we talk about our home safety, public safety, but when we talk about safety in the space, and that space research organizations are doing so many important breakthrough initiatives. And we'll learn from you today that something different what we have not heard of so far. I'm sure that is there because of your background and the work you are doing at present. CoE-SEA welcome you, and we look forward with your kind support and cooperation for the CoE-SEA. With this brief note, I request Mr. Nelson to give your talk today to the audience. At the same time, I welcome all the participants for this very important talk. Thank you, Mr. Nelson. Please.
Thank you, Professor Jay Maiti, for giving us an opportunity for a presentation here in such a big forum of IIT. Thank you, Professor Obi Krishna. Okay, so the topic for today's talk is prevention through design. I'd like to give the importance of this prevention through design with few examples what we practice here also. Actually, the prevention, every person who designs, initially it was a responsibility of the manufacturer, it was a responsibility of the factory manager or factory occupier to provide the safety for all his workforce who is engaged in the industry. Now, as per the new OHS code of 2020, which has been introduced in India, the prevention, the designer also plays a vital role in giving the safety requirements through its products, which will be supplied for the company. The erecting persons also has to provide the safety for the persons who is the end users of it. And every person who undertakes design and manufacture also should ensure the safety of their product, which will be supplied and where the persons will be using for long years. Any product or any machine or any facility, once it is designed, once it is there in the operational phase, the life expectancy will be around decades. So all these decades, the safety has to be ensured at the initial stage. So there are a lot of improvements which has been happening in the prevention through design. Why? Because instead of yeah, first I will give an introduction about our organization. And the Indian Space Research Organization provides the launch support for our country. It designs and manufactures launch vehicles. It puts the satellites in the required orbits. So actually, not just launching, the space activities is a technological hub. Lot of technologies will be developed. These technologies, if it is useful for society or industry, that will be transferred to industries also. It is an interaction between industry as well as academia. There are a lot of design activities like aerodynamic, structural design, mission design, special materials and chemicals required for launch vehicle operations, propulsion systems, energy systems, avionics software, ODEM systems, mission simulations, environmental testing. So a lot of testing, R&D activities, development activities are taking place in research organizations, Indian Space Research Organization. Whatever useful, like as a safety professional, the best example which I can give is that Class D fire extinguishing powder, that is a special dry chemical powder that has been developed in ISRO. You can see that ISRO patent for it. Even though you buy it from market, you'll get so many technologies get arrived because of these R&D activities, which will be useful for space as well as industries. So when we consider the safety of a space system, in the space faring nations or space faring organizations, uh, mainly these six factors has been taken into consideration. First one is the human safety. Human safety consists of the ground crew safety and astronaut safety. And next comes the public safety, the local public safety, general public safety. Where local public means the facilities which the public which is located near to our facilities. General public means wherever this launch actually ours is when we consider space, when we consider industry, it's a static hazards are in static way. It either get transferred from one point to other through pipelines, conveyor belts, or the process equipments. But here, the launch vehicle has such it is fully loaded with a lot of propellants and propulsion systems. It is passing through many of the countries. So, safety of all those persons has to be accounted when we go for designing any launch vehicle and designing the missions also. Next comes asset safety, that facility, whatever has been built has to be protected. It has to be protected from fires, the external fires, and the fire scenarios which can happen because of processing. Then comes the mission safety. Mission safety actually, when a launch is taking place, there are few inbuilt systems which has been incorporated in that launch. Like we look for a lot of components assembled together, which will be integrated in that vehicle. And these components can function, they can have malfunctions also. So there will be always a system which can bring down this vehicle to a safer location, even though mission has to be aborted. There are a few best example we can tell is that there is a distract system in all launch vehicles. You can see during some launches and all, if the launch is not happening in the particular defined path or the trajectory, it will be taken to a safer location and that will be terminated. The orbital damage prevention, there are a lot of debris materials which is there in the space. This has to be. we should minimize that when we send some items to the orbit. And general safety, which involves the non-involved work, where the construction and the transportation, driveways. Uh, so this is a brief outcome of the safety systems which has to be incorporated in our activities when we go for a launch launch operations. So here we discuss the things which will be useful for an industry, uh, and don't touch the mission safety and other things. So our systems are complex and it is very hazardous too. When we compare some products, what we make, what industry makes is that if industry makes a steel as a final output product, but this product as such it is safe. Only the material handling part will come to it. But when you compare the chemical which has been manufactured, this has to be properly handled. The chemical has got inherent potential of dangers. So it poses some few hazards either during the manufacturing, even after the storage, after the manufacture, even at the time of storage, and even at the time of transportation also. So the prevention through design it should start with the business concept. The business concept should be very clear. The persons who does that business should be very clear. The material what they handle and the activity what they do. Uh, Normally, in the early stages of my career, I was in the construction, then equipment operation and maintenance. So when we get inducted in an industry, uh, normally already it's a established industry, the systems are in place. We have to just manage the systems. But when it comes to a new design, a new facility design, new project designs and all, the safety consideration has to start from the initial state, that is when the users comes with this is the activity which they have to do, this is a material which they are going to process. We should estimate all the potential hazard with respect to that particular business. And then comes the selection of location and layout. The selection of location and layout plays a vital role in preventing cascading events and domino effects, thereby enhancing the public safety for the even the offsite emergencies also. So once the business concept is ready, we go for the location selection. Then comes for the design. Design. There are two type of design which I like to explain here. Is one is a building design and the process design. So mainly these three initial three: the business concept, selection of location and layout, and design, the process as well as building. This will be discussed in today's presentation. So we should have a strategy for managing the unknown. If it is an established process or some data is available within industries or some other places, it's easy to get the similar kind of best practices happens in the other industry. We can adopt it. But when we go for a totally uh, new type of activity, like R&D activities, many of the activities will be doing it for the first time. The best example which I can quote here is that when we consider a mixture, a fuel oxidizer mixture which will be used for a propulsion, uh, the how it behaves at different type of stimuli that is unknown. Like there are different types of stimuli. When you heat it, how it behaves. When you give an impact, how it behaves. When you give a shock, how it behaves. When you give a electrostatic charge, how it behaves. All these details are unknown. Why? Because there may be some literature data, there may be some modifications, there may be some value additions. Then only a new compound will be made. So if it is available still, there will be some deviations as per the literature as well as the actual data. What we do, all these data are unknown at the initial stage. So we should have a strategy plan. We should always have a highest safety threshold, applied risk reserve to accommodate all those unknowns. So once the item is formed, we can evaluate all these parameters, how safe it is to process or how safe it is to handle. When we go for when we take the example of firing So some item has been made, it has to be tested. So we don't know how this test is going to behave, like how the projectiles will be flying, how the blast energy will be happening, how the blast pressure will be acting onto the nearby facilities. So there will be a always. So in that case, first if we are doing a testing or firing, we will go for a totally enclosed type, and we'll get the data. And this data, and if you feel that okay, this test can be carried out in open space with proper blast wall and test pits areas and all, we'll do this test in that area. So always for mass, the what is the industrial production, the safety as well as the safety threshold as well as the production both has to match. Otherwise, the industry cannot run. So there will be a calculated risk. There will be applied risk reserve. So this applied risk reserve can be brought down, and the calculated risk also will comes down when the actual things of the item or the process is known. So I will explain this with a case study. Actually, this last year, 2020, this incident happened at Beirut, Lebanon. The compound which was involved is ammonium nitrate. The first thing what I thought, many of us also would have been thought is that it is an oxidizer. How this could have given a devastating effect like that? Why? Because first time in my life I have seen a blast wave which has been captured in video cameras and all. Even the some videos where the persons were traveling in a boat in that area, you can clearly see the blast wave coming and hitting the boat. So how this ammonium nitrate has given a such a devastating effect? From this picture, you can see the place where it has been stored is totally devastated, gone out from that area. Nearby, all building has been damaged, and the damage has caused very great loss for that particular area as well as the country. So this is a closer view of it. We can see how the oxidizer, which was considered as an oxidizer and fertilizer, how this has caused such a big damage to that area. So first we have to understand what this compound is. So we should definitely clearly understand what the material we are processing. So ammonium nitrate, when it's considered for the UN classification, the UN there is a unique UN number allotted for all kind of compounds which has been listed. So when you consider ammonium nitrate, there is a UN number, the UN number 0 ammonium nitrate. It is classified as 1.1D. The 1.1 is nothing but when you take the UN classification, it is classified as explosives. 1.1 is massive mass explosion hazard. So utmost care has to be taken when we handle 1.1. And this other compounds like 1942 ammonium nitrate is considered as an oxidizer. This 5.1 is nothing but oxidizing substances. 2067, that is also as oxidizer. It is categorized 5.1. You can see it's an ammonium nitrate based fertilizer. But if some additives are there, like combustible materials, it can even give a devastating, the total property of it changes. And even in case of a fire, ammonium nitrate actually does not burn. However, it will support and increase the rate of combustion in the presence of flammable or combustible materials, even in case of absence of oxygen. That's why this propulsion is been it is used as oxidizer in many of the along with fuel components in many of the propulsion systems also. So unless the total severity potential of this compound is not known, this kind of incidents can happen. Why? Because normally oxidizer does not require any separation distance for storages and all. So it is stored in that area. It would have been stored in that area. And once a fire happened, all this came together and given an explosion. So I will take one more example of LPG terminal, which happened LPG terminal incident, which happened at Mexico City. Here also there was, we can see in that picture how beautiful it has been packed. architect has played a very good role in packing the materials in a very small compact area. But once one explosion happened, it has resulted in a domino effect. The projectile has flown to a distance of 300 meter, and there was few modifications which was done the hazard identification. So you can see no formal hazard identification process was carried out. Lack of awareness of potential death talk if a believe occurred. Why? Because you can see the nearby facilities and the populated area is very near to these facilities. And there was a management of change. Two additions were the plant layout and inadequate positioning of tanks has resulted in this kind of devastating effects, which has resulted in a lot of floods and as well as a loss of life for the public who were staying nearby. This is actually a reference which is taken from Mary K. O'Connor Process Safety Center. There is a data analysis for 30 years with a number of incidents, and the outcome is majority plays the mechanical integrity and the land use planning. If the land use planning is done properly, many of these incidents, this where the consequence of these incidents could have been reduced. Even you could have reduced the fatalities to a very drastic number. So when we consider the prevention through design, uh, it's not only the small devices what we consider. It's not only the machines what we consider. We should consider a holistic approach for our total business itself. Next one more incident. It's This will help in getting more understanding about the importance of the location. It's a Pepcon incident which has happened in US. Here the compound was ammonium perchloride. It is used as an oxidizer in rocket fuels. Here also a fire happened. It has given a blast, but you can see out of 77 employees, 75 got escaped, running or driving away from the facility through desert. And the nearby facilities that was not fully affected because of this, because there was having a sufficient separation distance between the other nearby facilities, and they were differently able. One was not able to escape, and one stayed back for to alert emergency dispatchers of the situation. And even the firefighters were approaching that area. The company employees was given the warning there can be a devastating explosion. This is what even a major incident when we consider the industry part, all the employees will be properly trained in case of emergency scenario. So handling an emergency scenario inside a plant, which will be much easier when we go for an offsite emergency. So when we, according to our business, we should select a proper location to get this advantage. And here also you can see ammonium perchlorate. 0402 ammonium perchlorate is classified as UNHD 1.1, and 1442 ammonium perchlorate is classified as UNHD 5.1. So here also it is not actual. It's even though it is considered as oxidizer, this oxidizer can behave differently according to different stimuli which is given to it. So always when we go for designing our plant, we should consider under scenario and offset and evacuation required. How do we do it? This always has to be kept in our mind. I will give an example with the major space port of the world. You can see all these major space ports are located, most probably in a beach side. You can see the Kennedy Space Center, it is almost near to a beach. Our Sriharikota, which is there in Andhra Pradesh, it is also near to a beach. This is wisely chosen. It is to have a safe launch window for the launch vehicle to take off and to get into the space without affecting or causing much damage to the general public who are staying nearby. You know, this vehicle will be passing through other countries also. And there is a system installed to it that is called distract system. If the launch is not happening in the trajectory, that will be distracted and made to fall into that C itself. That is an extra abundant precaution for safety has been considered when we do this launch operations. So how do we do it? That is practically how we can approach this kind of situations at the initial stage. That is what everyone is looking for. Mainly the industries, they look for what they have to do, what is the best practice. So the best practice here, this system we follow actually here, and there is a safety review system for all the activities, starting from the activity concept. So when the here one scientist he wants to do one particular activity, or a project team has to do some project activity, testing, development, testing, and processing. First, the activity concept will list out all possible potential hazards. There will be safety review for that, whether it is okay to do it in our locality or it has to be done in on any other centers. So once it has been listed out, the suitable location has to be identified. The location has to be reviewed with respect to the hazard potential of the proposed activity, proposed facility, and also with respect to the nearby facilities. Why? Because these cascading events should not destroy our facilities and get into ashes. Always we consider what is the potential hazard of this facility and nearby facility. Whether we have got sufficient distance to put this facility here. Practically, what we do is that we put circles with respect to this facility and other facility, and with this any facility coming inside that circle um, will not be considered. So that location will not be considered. Suitable location has to be selected with the available area. Then after the location review, there comes the building design and the process design. The building design, there will be a lot of literatures available. There are a lot of good practices which is happening in industries also. Then comes the process design. The process, many process, if it is a first time process, lot of consideration has to be done. So building design has to be taken care with respect to the process what they are going to do it here. If it is an energetic item which they are processing inside that facility, the process hazards should be contained in that building itself. It should not be transferred to the other locations or other areas or nearby facilities. So accordingly, the building has to be designed. For example, if you go for a storage, if energetic materials has to be stored in some buildings, and storage facilities has to be totally isolated, we should have the blast wall, metal protections. So the process, what the process has to be clearly defined. That process has to be designed. Then accordingly, the building has to be designed in such a way that the hazards of this process, the outcome, the worst case scenarios has to be contained or minimized with that building itself. Then only it comes to the construction stage. So before construction, all these clearances has to be obtained. Then only the construction should start. So this total concept, uh, prevention through design, is not with only with the equipments. It should start with the activity. In the activity itself, the any energetic materials, we are able to replace it with the less sensitive materials, but you will get the total energy requirement equal to the required the initial item which we have selected. So we can substitute the items at the initial stage itself. Once the construction starts, practically it is difficult to do any incorporations into the drawings. Why? Because what we have to do is that get the drawings, review the drawings at initial stage, do this modification at initial stage, then give it for the construction. So so the main advantage of this is that ability to influence is the major thing when we do this kind of previews at the initial stage. Once it is there in the drawing for execution, it's very difficult to change the structural part and other very difficult to incorporate the safety features which is required at the time of consent for the process which has been already defined. So concept stage is the best stage for the incorporating, for identifying the hazard, identifying the control measures, and incorporating it in the design drawings. So when the project schedule goes up, if it is not done at the initial stage, what happens? Many times the drawings is not coming to the review teams, safety review teams. Definitely, many points will be missed out. And when the time of commissioning, the PSSR has to be done. A lot of compromise has to be done in the PSSR. We know this is not going to happen, but still the facilities may have to be cleared. So always do it at the initial stage. And when we come for the process, we should go for the process hazard analysis. Accordingly, the building design features has been incorporated. Mainly four things we should consider for the process hazard analysis is that environmental release and explosion scenarios. Explosion scenarios, it gives the blast effects and the overpressure at that particular distance or nearby facilities, whether we have got the separation distance. Fire scenario, nearby potential fire hazardous installations. Fire suppression system. Many facilities, when we deal with oxidizer and fuels, some chemicals, if fire happens, there is no other way. We have to just run and escape. That's what in the few case studies also we explained. So in fire scenario, the fire suppression systems should be in place within the building itself. This has to be considered at the initial stage, then only the implementation will be happening. After construction, once the plants start running, taking the shutdown and putting in major firefighting systems in fire suppression system inside, it will be definitely result in the loss of production. So safety should be in parallel with the production activities. It should be like a rail, should not meet each other, should not far apart. Both should have a both should go parallelly. And the fire scenarios and the toxic release scenarios, we should definitely consider the time weighted average, whether it's safe for persons to work, STEL values, IDLH values. If we are dealing with highly toxic chemicals and all, even though it is minor quantity, we should first go for the substitute. We should go for the substituting the item. Even if not possible, we should have proper scrubbing systems and then letting just like they're letting it to outside. Uh, we come for the layer of safety protection and process design. Uh, First, when it's a process design, we should go for only the minimum quantity. Whatever required only has to be brought to that facility for process operations. If possible, go for the remote operations. First, we should arrive the safety parameters. Uh, this happens when we design the process for the first time. Once the safety parameters is defined, the required adjustments can be done in the quantity. Quantity can be enhanced if the safety parameters are within the limits. Then next layer of protection is separation distance. This is meticulously followed in our facilities. As I told, we don't want any domino effects to take place and take the total buildings to a collapsing situation. And then comes the process when it process controls and safety controls like instrument controls, alarms, and interlocks. And then comes the emergency response system, that is public safety. How the public is, how far they are, how the emergency scenarios has to be communicated to them, how they can be trained. This all considers, this all accounts for the layers of safety and process design. This has to be considered the initial stage. Then when come to the understanding the uh, coming to the actual scenario, how practically this can be done is that understand all the potential hazards, move the potential hazards to the location where the impact can be made under control. And the figure itself, you can see in the oil rigs and all the flyers will be slightly put apart from the oil rig, so that even the flyer switch offs for a few minutes or few seconds. That is not going to the toxic gases will not be affecting the persons who is working in the platform. A lot of computer-based models are available to estimate this kind of environmental release scenarios, heat dispersion, models estimate vapor cloud dispersion, heat radiations, and These models provides adequate consequent estimate for site selection process. Even the experts who are expert in this computation fuel dynamics, autodyne and all can simulate this data. But in industry, when you consider industry, this kind of expertise is not available. But there are few softwares which give the once you give the input data, this data can be used to simulate this kind of results. There are few softwares available. Fast is one of the software. So with this data, we should go for this location. And how the facility siting and the investor has to think is that investor has to think the facilities nearby, how the proposed facility is going to affect the nearby facilities, the resident area, the future town expansion, and investment. Actually, investment he has to do it in real estate. That means proper spacing and separation distance has to be put in place so that if one goes wrong, the total business is not going to an abrupt stop. Even if these details are not available, there are few prescriptive methods for taking these considerations. Like India, we can take the explosive rules 2008. It gives the safety distance for manufacturing factory of magazine of category UNST 1.1, 1.3, and forwards. So it gives the distance criteria between distance requirements with respect to the quantity, with respect to the process buildings, with respect to the outside facilities, offices. It also gives the wall thickness required to prevent this explosion effects to contain there itself. OIS2 also gives the distance criteria between the facilities like block. Table 1 gives the distance criteria between the blocks and facilities, equipment within the process units, then tank and offsite facilities, then LPG facilities, then LPG storage vessel and boundary wall. This is with respect to Indian scenarios. When you go for international scenario, the CCPS gives the guidelines for citing the facility. So it clearly gives how the office to the parking, office to the process areas, office to property boundary, parking maintenance warehouse, and parking maintenance warehouse to property boundary and to property areas, process areas to tanks, tankage, then utilities, then process areas to property boundary, tankage to property boundary, utility to property boundary. So actually, and, when you consider explosive rules, or if you consider this check also, it is the process inside quantity distance and outside quantity distance. Process inside quantity distance uh, actually gives the details of distance criteria required within the process buildings of similar facilities. And outside quantity distance gives the distance criteria for the general public and general roads, like of general office buildings. So we require a lot of data to get this uh, put in place. Like when we okay, so that lot of data has to be selected at collected at the time of initial concept phase. What is the item what we are going to process? If it is what is the given classification, the compatibility group, the quantity what we are going to process. If it is chemicals, the stell values, TWA, IDLH, the quantity of the chemical what we use, how much we use. If we have got any suitably replaceable material, chemicals, that can be selected at that time. When you go for the pressure systems, the pressure volume, it gives account for the TNT equivalent of pressure volume, how much a TNT equivalent is there when you're going for the pressure testing areas. If that goes wrong, if the pressure test, during the pressure test, the article breaks, what is going to the physical explosion effects onto the nearby rooms or nearby walls? And what is the safety mechanisms? How this safety mechanism has been routed out? Um, how many mechanisms are required with respect to the potential when it comes to material handling? Why? Because at the time of location and the building, these details are required for the designers to design. What is the total capacity required? Approach for the maintenance, and then distance between the nearby buildings, the gas, what is the storage, where is the storage area, type of storage, proposed method of handling, If it is any radiation buildings, type of source and energy level, and then waste generated, quantity generated, proposed method of disposal. So how do we collect this data? Um, if you give a hard copy for the users or engineers or scientists, many of the columns will not get the full data. So we have developed a software. The software captures all this data. The users has to definitely enter all these details. Then only it will be they will be able to submit for the safety reviews. So this data is visible to all the experts uh, who take decisions. It is visible to designers. It is visible to safety team. So transparency is there when all these details are entered into online through softwares, and all can put their own comments and uh, proper analysis can be done when all these data details is being listed out at the initial stage before the design. So once this has been put in place, once this data is collected, we should go for the building design. So it gives the enough information for selecting the suitable location and how the buildings has to be designed. So process is almost getting finalized at this stage. Then only the building will be uh, building designs will be taken. The initial system structural and all will be done, but the wall thickness and other things depends upon the exact process what they are going to do inside that labs. So I will try to give a basic root cause why there is a deviation between the designer, why safety has got lot of recommendations at the time of design drawings. It is designer perspective. This I took from my own experience when dealing with the project. The designer perception as well as the actual hazard perception is totally different. Right? When designer takes the hazards, already he's having proper stairs up to the access areas. Well, consider a facility which is having only single floor and AC units has been put above it, like cooling towers and AC units has been put above the first floor. So the AC team has to access into that area frequently. Of course, the process team is not going to operate the AC systems and all. The frequent access is required for the AC team into that area. So, simple and monkey ladder providing that point. When we design this facility, these facilities are designed for next 20 to 25 years. So all these 25 years, you see the number of times the AC team has to climb up this monkey ladder. And sometimes they have to climb up with material for maintenance activity. So the frequency is getting increased at that point. So we should also consider the height. From this floor to reach up to the other floor, the height is only maybe some 4 meter. But when he falls from that to this area, the fall height is only 4 meter. But when he falls from the other side, it can result in the height may be some 10 meters, 15 meters, where a person can die itself. Fatality can happen. So when we this is the actual what happens with a designer. So design is coming from any part of this world. When we go for industrial plants also like that, we don't know from actually from where this design is come. Only the project team, the project engineers may be knowing. The safety team may not be knowing. So the continuous interaction is required at the designer with the designer and the review team to make this put this access requirements in place at the initial stage itself. So it is easy for them to give a proper stair that does not cost much comparing with the project cost and all. But only thing is that okay, if they are able to convince that this is there is a proper facade is there, proper access is required. In that case, providing a stair that they will definitely consider. Even parapets and all. Many times upper portions are left without parapets. Fall protections are not there. So when they go for the roof maintenance and all, roof maintenance, water tank cleanings, AC maintenance, there is a potential fall hazard. So if you provide a parapet, you're totally eliminating the hazard at that time itself. And this providing a parapet is not a costly affair at all. when we do the main slab casting itself, nowadays a few designs are coming like that. The parapet is also built along with the main slab casting. They will bend the TMT rods and make the parapet very easily. So only thing is that the necessary input has to be given to the design of the initial stage. So when safety comes for audit after the construction, this is not considered. We'll recommend for proper stairs at that area. And putting that stairs, as I told in the previous slide, putting that stairs will be a costly affair. Again, a separate tender has to be bought, contractor has to be bought. All these procedures has to be done from starting from zero to realization of this proper stairs. So designing, giving the designer what is the actual hazard that should properly communicated to the designer by the safety team or the designers or the project teams initially itself, so that they can do these things at the time of design itself. So when we go for a building design, in India, National Building Code 2016 has beautifully listed out all the requirements for the proper access, how the access should be, how the height and emergency exit grids. Everything has to be properly detailed. Even the stairs and handrails, the stair width, stair height, the thread height, the riser and the stair width, everything has been detailed in the National Building Code. So sometimes, actually, what happens in the background is that there may be already a standard design, a standard drawing for stairs. So that is getting copied in upcoming designs and all. So if we can give a correction at the initial stage itself, the hereafter the further drawings will be also corrected with respect to a proper standard. So standard has to be properly communicated. The designer should be properly trained in the standards. Uh, and if you go for according to the process, if you are using flammable material, flammable liquids in that particular bay or that labs, the electrical fittings and the electrical selection has to be done very appropriately. It depends upon zone 0, zone 1, zone 2 classifications. The light selection, the power sockets, everything has to be selected with respect to the item what we process. That is a flammability. If it is a flammable material, definitely we should go for it. If the flammable storage is also there, definitely we should go for it. And lighting protection systems, electrical isolation devices. So how do we actually do this? In the civil part, the civil drawings we should obtain. We should look for all kind of these standard records. Standards are met. The drawing has to be compared. Any details has to be missed out, has to be highlighted, and this has to be incorporated in the drawing. Why? Because this civil drawing is going for construction. Unless it is not there in the drawing, it will not be constructed also. In electrical part, the line diagrams has to be obtained. This line diagrams gives the total details about the tripping devices. Most probably, after the construction, some maintenance activities, small maintenance activities, is portable tools may be used. So there should be properly rated power sockets for this human protection, 30 milliampere. So unless we look into this line diagrams, this tripping device ratings will not be known to us. So basically, why this unsafe act is been done is that the maintenance team may come for maintenance work. There will not be proper power socket routed from 30 milliampere. So that they will do with whatever possible, whatever available in that area. So instead of that, and sometimes they may have to use the extension boxes. So if we can identify this kind of maintenance activities, frequent maintenance activities at the time of the design itself, uh, and this can be the power sockets can be given at that particular locations, so that extension box totally can be avoided. Even the cable routing, if you consider for a machine shop, there will be a lot of machines which will be assembled throughout in a very serious way. This machine, as the cable routing has to be made proper. Underground routing, proper trenches can be made at the initial stage. After constructing, demolishing and cutting a trench is very difficult. Most of that will not be done. Instead, they'll put a pipe. There'll be a trip hazards. So The saying is we don't stumble on mountains, we stumble on stones only. For example, what I can tell is that if a consider steel plant, a ladle molten metal is being handled in the ladle. They all know the potential hazard of that ladle. If it falls down, if ladle punctures, the person who's standing nearby will not be there. So they even if it falls, also you will the incidents will not cause that much fatalities or injuries to the people. Why? Because the hazard potential is small. But when the small things considered, when you consider the trip hazards, when you consider electrocution hazards, when you consider the proper access, these are the places where fatality is happening inside industries. We may complete a project without any injuries, construction project without any injuries. But once the plans start, a person may trip and fall into a place where it can result in a fatality. Sometimes even the electrocution hazards can result in fatality. And many of the fatality cases you see, it is mainly because of some small reasons which could have been prevented uh, even at the time of design itself has resulted in this kind of fatality. So cable routing, power supply location, capability of being locked out. Now all the electrical equipments comes with this capability of being locked out, but the old plants and all will not see this capability of being locked out. And we consider the HVAC, air conditioning systems and ventilation systems, the exhaust systems. If chemical processing is there will be exhaust system. This fume cupboards will be the fume cupboard exhaust should not be routed to nearby building or nearby window. Why? Because this toxic is chemical has been absorbed and pushed to the some other area where the persons are working. Definitely, we should consider the if it is overhead tanks and all is overhead water tanks, overhead utility services are there. This air toxic air routing should not be to that area, even though it is small labs or fume cupboards. Major things it will be routed to flyers, not to flyers from gas holders or the generating what is it gas generating units after the blowing operations and all everything will be having a flare. But when we consider the small things, the small lab chemical analysis lab, definitely there will be a fume cupboard or a exosystem. This routings has to be very proper. It has to be into a place where no persons are there. These effects will not be causing any ill health for the workers who is working in that area. When we consider the proper access, you can see the distance between the crane and the wall. This everything details will be known when you get these drawings. When the civil drawings is all these dimensions will be marked. So definitely we should consider proper width is for the persons to move apart. Why? Because many cases has been reported the crush injury between the crane and the wall also. Anchor points when handles, it's better we provide handles at both locations, both areas with free passage. Even some industries, some steel industries have seen proper access is provided for the light. Catwalk is provided. It's a full structure. It's catwalk is provided for the safety of the electrical maintenance persons. Some buildings it is not there, but if, when we procure a crane, the crane itself can have a safe area for a person to stand and work. Provided it has to be locked up properly and the crane should be stable and the what is the P card systems has to be removed. They can proper access is there. They can work from crane also, but better if possible we go for a catwalk for the light and put the light in easily accessible locations so that it is easy for the maintenance team. So that's what the construction safety has improved a lot. And many projects we are able to complete without incidents, but the maintenance point of view, maintenance persons may get injured because of this kind of poor designs. Even there will be fatigue. Then lights, the LED lights, whichever comes in the compact way, it will be totally mounted onto the seal. But you consider the person who has to do the maintenance activity. Why? Because he cannot reach up to there. He has to look to the above roof and he has to work. So consider that one person is deployed for this total location. He has to do this maintenance activity on this overhead LED lights, which is ceiling mounted. The fatigue will be the neck will be paining. So if it is a uh, hanging type, it is easy for him to do the even he can take it, put it in the proper platform, do the maintenance, and put it back. So anchor points plays a vital role in preventing a fall. Uh, when we construct our own houses itself, we will be definitely putting this what is hooks at the sunshade, so that at the time of Diwali and all, it's easy for us to put the lights and all. So anchor points actually saves a person falling. Why? Because many persons does not do this anchorings because of lack of anchor points. So when high potential is there, frequent access is required. Definitely provide the anchor points so that belt anyway it will be available. So anchoring a belt to an anchor points, it is easy for them. They will do it also. But if it is not the tying a lifeline, that will not be proper. And the usage of this lifeline also cannot be ensured. So coming to the fire protection systems in the building design, fire detection systems, fire protection systems, fire alarm systems, everything has to be considered. It is fully given detailed in the national building code with respect to the area, with respect to the height of the building, with respect to the hazard classification, and with respect to the building classification. So one point which I like to highlight is a relative position of smoke detectors with respect to AC ducts. If smoke detectors put with just near to the AC ducts, the AC duct will be always blowing the air towards that. The smoke will not be coming towards smoke detector. Smoke will be moved away. Why? Because if AC duct is there will be a return path also. The most probably the smoke will go to the return path. So even there are duct detectors, but a relative position of smoke detectors has to be considered. Fire suppression systems like sprinklers and all has to be considered. If the firefighting, if it is as per mandatory requirement says we have to provide it, even though it is not a mandatory requirement. If the practical firefighting is not possible, like once you consider the radiation facilities where the radiative source is there, we cannot deploy the person in that area for this firefighting operations in case of fire. So even the propellant handling facilities, the explosive facilities, it is not mandatory to provide uh, even though it is not mandatory to provide a fire suppression sprinkler system, it's better we provide it. Why? Because doing a firefighting on a propellant is impossible. Why? Because it's already mixed with an oxidizer and fuel. So even though you put it water also it will burn. That is the way that it is being designed. Even it go to space also it is burned. Why? Because there is no oxygen. So in that case and all, depending upon the hazard potential, we should go for the protection systems. And coming to the equipments, guardings, isolation devices, maintenance accessibility, and the noise level. All these newer equipments comes with the noise level of operations. If some equipments, whatever the possible noise reduction is not possible, required noise reduction is not possible with that machine, we should go for acoustic protection. So all these details has to be collected at the initial stage. Accordingly, if noise level is very high, we should go for acoustic protection of the room itself so that the reflecting noise can be minimized. Uh, there are few facilities we do like that, like riveting operations and all. There are riveting operations required in the spacecraft systems. The riveting facilities will be provided with acoustic protections, so that the person working the hazard protected. Why? Because they have to do this activity for next 20, 30 years. If you provide it, if you incorporate in the drawing, it is easy to provide. They will provide it, and that cost will be estimated at the time of initial cost estimation by the project execution team. Um, then auxiliary items like drinking water, pneumatic air supply. So then nowadays, lot of pneumatic tools are coming. Many of the electric tools are replaced with the pneumatic tools. So the electrocution potential can be even minimized. The shocks can be minimized if you use a pneumatic air. Only thing will be pneumatic drills and all of it is available. If the proper line routing is been done at the initial itself, we can have a QC-DC connector so throughout the facilities. We can do this kind of operations at anywhere, any place required. So all these details can be incorporated when it is defined at the initial stage itself. So when we have to come to the process safety, when we go for the process safety, first we have to generate the safety data. For this data generation, the bare minimum quantity will be used. We will limit the workforce. We have to go for the remote operations, trial runs. Trial runs, as I told, when we do for the first time of some compounds or some chemicals, the machine has to be pushed to its limits. What all outcomes can be done, what all outcomes can come with a machine going out of control. Everything has to be listed out. Sometimes we may do trial runs with the dummy materials of similar mechanical properties to know how this machine behaves when we push the machine to its limits. Once the data evaluation is done, once we get the impact sensitivity, friction, permeability, EST, all these details, we can decide how this process, whether we can allow the persons at that for the processing, whether persons can be, if required, can go nearby. Otherwise, always we try for a remote operator. We expect that it is going to be giving a blast, or if it is going to give a devastating effect, but a person should not get injured. And coming to the process safety, this will be applicable for the batch operations or initial operations. When it is established operations, we should have the basic. When we go for a process operations, definitely it's a chemical process you consider. There'll be a reactor, there'll be a tank, there'll be basic process control system. The basic process control system takes the feedback with the one input parameter. It gives the commands for closing the valves, operating the valves. And there is a additional factors what we have to consider is that if the SCADA hangs, there are a lot of automation systems which is coming into place. A lot of PLCs also coming into it. If the SCADA, most probably the process operations will be done with the SCADA. If the SCADA hangs, how our system is going to behave? If our PC hangs, how our system is going to behave? If software bugs are there, if PLC bugs are there, how the soft system is going to behave? So what we have to do is practically we should overload this SCADA, overload our PC, push the PC to its limits, and see whether we are able to operate this system as per our required process conditions. We should consider that whether the process event can cause a tier 1 incident or a tier 1 event that is with a greater consequence, or tier 2 event with a lesser consequence. Uh, if it is a catastrophic event, definitely we should not go for a probabilistic analysis there. Why? Because once in a blue moon only it will be happening, but that should not end our business. Always we should consider a catastrophic or significant events with the utmost caution. At the initial stage itself, like studies like HASOP and FMECA and what if will reveal some of the additional requirements at the process design stage. I will give a best example for the SCADA hanging is with one steel plant. There was a conveyor belt which was taken for maintenance operation. So the permit to work system will be in place. The electrical power will be isolated, but most probably SCADAs will be on only. The operator sitting in the control room will be knowing about the real condition of the equipments, either in off condition, it will be green, red color, whatever it be. So after the maintenance work, the permit was returned, electrical power was isolated. Before the electrical power isolation, the emergency stop as well as pull cord was set back. It is original position. So normally when we give a command, it was supposed to operate when we give a command from the control room. There will be a warning siren. The siren, the hooter rings, and after a delay only, the belt will be starting. That in a very slow way. But after one maintenance, we observed that when the time when we reset the emergency button, the belt suddenly started. So when we analyzed this, we came to know that when we drag this mouse, in the SCADA, some switches, some what is it, the instruments were switching on, some device, some control valves were, some motors were switching on, some were switching off. So that is actually a error in the SCADA system. It should not drag when we drag a mouse like this, it should not switch on. We should give a proper command, then only it should switch on. I will give one example with this software bugs. Is that this recently there was a launch towards International Space Station. The launch was launch cargo. This cargo was launched. It was into the orbit, but orbit also requires a orbit correction to align it with the International Space Station, get it uh, docked. So this firing has to take place at the required time. So this firing didn't happen. What happened is that there was when they analyzed, they found that the clock timing was totally different. So this clock time, the system, the system brain used this is not its time to fire the engine, so it didn't fire it. So there are a lot of examples when we consider for the PC hanging situation, SCADA hanging situation. So we should always have a rugged system. We should push those SCADA and PC softwares to its limits, dig out all the bugs, and then we should go for the actual full operation, continuous production. So with this, I hope that I give an idea how this has to be designed at considered at the initial stage. And the way forward is that we should always have a defined process. We should have the estimate the potential hazard at the initial stage, design with safety. There will be at MOS, management of change will be there. Then only we can sustain in the market. According to market conditions, according to the new emerging scenario, we should change the process also. We can adapt the process, but definitely we should review the management of change very rigorously, starting from the business concept, starting from the location where we are going to do it. The building is capable, the facility is capable of doing it. The facility readiness has to be ensured. Then review and continual improvement. So this with this we can go a sustainable model, uh, starting from the initial stage of design. So once the manufacturing is in place, then the normal procedures, normal what industrial best practices will be coming into picture. So I hope this is end of the presentation. We'll go for a question and answer session now.
Thank you, sir. Very holistic view of these implementations. I mean, many of the industry practitioners can directly relate to these improvement initiatives. So I would now hand over to Sovik for the Q&A session.
Yes, ma'am. Thank you, ma'am. Thank you, sir, for your nice talk. And the talk was very interesting. Sir, we have received so many questions. I am taking some of them. Like, do C HAZOP studies is carried out to ensure safety of softwares as well as control devices?
Yes, hazard study helps in that. Actually, we can consider that scenario also. That's what I explained here. The software bugs and all has to be brought out with hazard studies. That you have given you can consider the scenario like this. You are giving a command for switching off a valve. It's not getting switched off. So in that case, what is a control measure? With the system, we will be taking care. Why? Because when we design it, there should be if it is a higher consequent event, there should be a system itself has to take care of the thing, has to control and bring back to the required position. So that consideration is possible with the hazard study. For that, the guide bit, what we can use is that it didn't see if I can some specific processes that I can explain. Let me think. Yeah, we consider a process of opening a valve at the required time. We are given a command that the valve is not opening. From SCADA, you may not be able to open it. Is there any manual override that we have to check? Manual override is SCADA if it's not opening, manual override. If manual override is not there, how the system is going to behave, how the system is designed so that it comes to the original required position or to the safer location, safer mode. This is possible with the HAZOP. With specific example, I can give more comments on it.
Yes, sir. Yes, sir. Thank you, sir. Now, sir, the next question is that how can we address human error, or you can say human behavior during the prevention to design stage?
Yes, human behavior has to be considered very much. That's what initial stage we expect that he is purposefully doing a error. It should not be affecting our system. Like few systems for the human error detection is that if a person is operating a lathe, CNC lathe with this cover in open position, uh, the best system is that you put an interlock. If interlock is open, the system is not supposed to start. So that comes at the stage of design of equipments. Design of equipment. When it comes to the design of buildings, that's what I told. Design of proper approach is the person can do unsafe act, human error. Like when we send a person to maintenance operation on a crane, there is no guarantee that he will be always using the fall protection. Best thing is that you go for proper handrails at all locations, all possible locations, and provide the maximum protections, safeguards with this kind of handrails, proper access for the working person. We should consider from the worker point of view. It is not the designer point of view. Should be worker point of view. If we do like this, what can be the control measure? What should be the safety precautions?
Yes.
Uh,
Thank you, sir. Now, the final question is that do you use pre-startup safety review for the last stage of review, like before starting any facility or launch of vehicles?
Yes, sir. Definitely, we do this pre-startup safety review before the operation. So, the PSSR checklist is already given to the users at the initial stage of construction, as well as while the procuring of the equipment. PSSR checklist is very detailed one. It consists lot of factors, mechanical integrity, everything is the electrical, then what is fire protection, environmental, offset scenario, proper train, everything is there. So this checklist is already given. So when they come for the safety review, operational safety clearance, they will come up with this kind of compliance checks. So it is easy for them as well as us. Why? Because what we are going to audit is already communicated, and they will come up with that. So it's easy for them as well as safety team to do this audit and give the operational safety uh, clearances.
Yes, sir.
And in the launch operations, as he asked, in launch operations, so launch operations, there is an automatic launch sequence. There is a checkout systems which consider all these things. There is an automatic launch sequence. It is automatic. Once you put into the automatic launch sequence, all these things are taken care by the system itself. Before that, the checkout procedures are there. Everything has to be to come through the checkout. So this checkout ensures this working of these items is being properly. The functionality of this item is ensured during the launch, and other as you told, pre-startup safety, yeah, PSSR. It's not actually PSSR checks. It is a part of process checks when we go for the launch operation. Why? Because there are a lot of barriers that we put to prevent the hazards. Like, for example, what I can tell is that explosive trains are totally rotated and kept so that there will be even some initiating elements fires also. This explosive train is not getting transferred to the end motors or end motors. So there are few checks which has to be done prior to launch. That this motor has to be rotated and the explosive train has to be the initiating train has to be properly aligned. Then only this systems will be functioning. So that act as a lotto system also, like positive isolation of the explosive trains. So that checks has been done. It's not PS. I'm not sure. It's not fully PSSR. It is actually process requirement. So process checks are done. Everything there will be proper checklist. Doing any process, doing any checkout, doing any assembly, there are proper checklist. A quality persons will be ensuring all those proper checks has been done properly for ensuring the functionality.
Yes, sir. Thank you, sir, for your clarification. Now, I would like to request Professor Obi Krishna to formally greet vote of thanks to our expert speaker.
Thank you, Savik.
Yes, sir.
Nelson, you made it really happen. Now we all understood why ISRO experiments are very, very successful across the world. The foolproof systems which have been put for successful operations without disclosing the confidentiality things very clearly you brought out so that people can understand. Thank you very much. Yeah, you are right. The PTD prevention through design concepts were on back foot for many years because the designers are reluctant to take the responsibility. Manufacturers were reluctant to take the responsibility. Even the NIOSH has got this concern trying to address. I'm very happy that the Indian federal government has taken the lead to make the designers accountable, manufacturers accountable, so that PTD will take off its own lead. Of course, organizations like ISRO, we need not tell, but all across India, this PTD is going to take a big lead. Very nicely you brought out also the designer's perspective and safety perspective. It is the big thing. Designers look up functionality, safety perspective they miss. But with PTD and all this, very clearly, very well you have explained with the examples. Nelson, I'm very happy. Uh, thank you very much. And to my audience, a lot of people have been sending requests that the videos are not loaded. Yeah, it was not loaded because of the pandemic issues. But tomorrow, Savik says, tomorrow all the pending videos will be loaded. You can see it. And unfortunately, we cannot share the PTDs because we don't have permission from the speakers to share the PTDs. PPTs. But you can see in the videos whatever the information you want. And thanks to the moderators, mom and her team, and thanks to the audience because of your good lecture, the audience again crossed 100. That's a good thing. People wanted to see what is happening in ISRO, and you've presented in such a way, audience are very well convinced, very well happy. Thank you very much. Thanks to all the audience for your support, and thank you, Professor Maiti, for presenting yourself and encouraging the speaker and the moderators. Thank you all. And Professor Maiti, you want to say anything?
I am thankful to Mr. Nelson. I just want to tell that it's a wonderful lecture. We all have enjoyed your lecture, and we are really happy and we are extremely thankful to you. Please be in touch with us and let us do something good also for the society.
Thank you.
Thank you all for giving us an opportunity for a presentation. There are a lot of background works which is happening behind this with the organizers. They were in continuous touch with me for this presentation. So, bottom of the heart, we as well as our organization thanks IIT Kharagpur for giving us an opportunity. We always look forward for more opportunities from our side.
Okay, thank you, audience, gentlemen, all of you. We'll meet again next week, next Friday at the same time with one more speaker from academic field. Thank you all. And good night to all of you.
Good night. Good night.
Good night, sir. Good night.